My name is Jonathan Reese, and I'm double majoring in electrical and computer engineering because I've always really had a passion for both hardware and software, and it's a great way for me to combine these two fields.
Hi, I'm Maria Garza, and I want to major in industrial and systems engineering. I actually became familiar with the major because both my parents studied it, and I want to major in it because of the flexibility of the major.
Hi, I'm Megan Sandry, and I'm planning to either major in biomedical engineering or chemical engineering. I'm still not exactly sure, but I'm ready to see where this school takes me.
Hi, I'm Simone Wilder, and I'm planning to major either in biomedical or textile engineering. It just depends on how CODA works out for me.
Step one of the design process is defining the problem. Our project was animatronics, and the objective is to design or build an animatronic figure that is capable of moving on its own. It has to fit inside a half-of-a-meter box, and it has to move completely on its own. We also had a $40 budget.
Step 2 of the design process is brainstorming and planning. So we decided to meet every Friday from 11:30 to 1 in the Lee lobby to work on our project. We decided to throw out some ideas first. An idea we first had was to make a giraffe that could eat a leaf, or a wolf pack symbol that hand could move into the wolf pack symbol. But we ended up deciding to make a wolf pack drummer that drums and hits a cymbal. So after we had our final plan, we decided to start making it and gathering materials. Our main material was an Arduino, which is our electrical component, and then we had a stuffed wolf animal and a drum and a bass.
So step 3 was to develop and test prototypes. So the basis of the idea was we had an Arduino Uno microcontroller, which connected via serial to our laptop. And this Arduino Uno would move 2 servo motors on the wolf to drum left and right, respectively, then send a serial command back to the computer itself, used a program called GoBetweeno, which then translates those serial commands to run a batch file, which in turn plays an audio file. So we're getting our Arduino to send the serial, which then plays the drum, moves the servo, and plays a sound effect with it. So as we were developing and testing our prototype, some issues that arose is that we had the plastic knives on the side that we use as our drumsticks. They would fall off the servo horn sometimes. So we had to make sure those were very secure. We used actually bread ties because we had them lying around and a lot of tape there. We had a lot of stability issues, so we made sure to make it extra tight. We used a lot of duct tape because we're engineers. We moved with that, and then our drumsticks wouldn't hit the drum perfectly, so we had to go into the code and adjust the different values back and forth. So all in all, it's a very, very successful project. We've gone through many iterations of it, and we can expand it. It's very modular, so we can expand it and get further and further as we need to go.
So step 4 of the design process is to finalize the design. For our group, we decided to add a drum symbol and add NC State logos for decoration purposes. And the final result of the project was that our stuffed wolf was able to drum in various rhythms all on its own. Also, we only spent $20 in supplies, so under budget, which is good, and we were able to fit it in a half-a-meter box.
Find better battery sources.
We need more giraffes.
Use linear actuators instead of servos.
More complicated music.
Pick a project you're passionate about.
Set clear goals that are measurable and you can complete on time.
Figure out what everybody's strengths are and collaborate together to create a great project.
Be organized, open-minded, and plan ahead.
Plan ahead.
Plan ahead.
Seriously, plan ahead. Fed is now over. So overall, Fed went very well for us. When we get there, we have to set up our project and check in. And once we check in, we wait for the judges to come around and view our product. And the result was we won. We got shirts like this.
So at Fed, we got the opportunity to meet a lot of prospective engineers, a lot of young children who had never really considered anything animatronic based or mechanical based, and we actually got the opportunity to show them how this is something that they can do, and we gave them a bit of ownership with it, so that I can take this project home and I can make something like this. So the servos we used were $7, and I made sure to tell people these are hobby servos, they're things you can go out and get. So hopefully we inspired a lot of people to not just consider engineering, but also consider NC State engineering, so they can see all the amazing things they can do with it.
Thank you to all our competitors. You guys were great competition and you guys pushed us to do our best in every way with our project.
I just want to say a special thank you to Dr. Baldwin for teaching a great class. And also we have to shout out Hanes Brands for sponsoring FED.
We'd especially like to thank our judges and all the volunteers who took the time out of the day to come out to FED with us and just help us have this amazing opportunity.
Thank you, Taylor, for sending all those emails and just reminding us to plan ahead.
Seriously, plan ahead.